All right. Welcome, everybody. Welcome back to Reimagine 2020 here. We have an exciting workshop for you. It looks like Harry here will be offering a demo for all the attendees. This will also be recorded and it will be available and accessible on the Reimagine 2020 website under workshops. So without further ado, I'll go ahead and introduce Harry here. Harry, thank you for joining us today and giving us your time to present this demo.
No problem. Happy to be here. I'm always excited to show the stuff that I'm working on. My name is Harry Pearson. I'm the Chief Software Architect for NEO Global Development in Seattle. NEO Global Development is the research and development arm of the NEO Foundation, and the Seattle office is primarily focused on developer tools. So this is all the stuff that I drive. You'll notice my contact information on this page. I love having conversations with folks that are using the stuff that we build. So please feel free to reach out, email, Twitter. There's other ways to contact me, which we'll talk about more at the end. Now, as part of this talk, I'm not really going to be covering much about the foundations of blockchain or smart contracts. I'm working off the basic assumption that the audience is at least passingly familiar with these constructs. So this is primarily about building contracts in NEO with C# and the recently released Python support. Python's been around in support for NEO for a while, but we've just released a new version this week that includes support for the debugger that we'll be seeing here. So here we go. So a couple of quick things about the NEO development model. The primary NEO code base, which is to say the code that runs on the consensus nodes that the NEO Foundation runs, is written in C# and runs on .NET Core. So it's all cross-platform. Everything I'm going to show you today is cross-platform. I'm using Windows, but this laptop was in the shop for about a week recently, and I have a backup MacBook Air that I was using for that week. So I can tell you straight up, all this stuff works in Mac, works in Linux. We test this with Windows Subsystem for Linux all the time. So whatever your favorite operating system, NEO will work with it. There are multiple implementations of the NEO stack other than the C# one that's maintained by the NEO Foundation. As I mentioned a minute ago, there's a Python implementation, the St. Petersburg, Russia NEO Competency Center. I'm butchering that name, that's not exactly correct. They implement a Go implementation. There's a TypeScript implementation as part of NEO 1. One of the NEO 1 gentlemen was presenting here at Reimagine a few hours ago. Java, Swift, C++. We want to be able to make sure that people are able to build decentralized applications for NEO, regardless of their choice of platform, regardless of their choice of language. Specifically for writing smart contracts, we support multiple languages as well. So that first list was essentially different projects that support some or all of the NEO development story. Smart contract development in particular is supported by a subset: C#, Python, Go, and TypeScript. As I mentioned, the Python folks, we've been working with them. They released a new version of their Python tool, which we'll see here today, that has better integration with the NEO Blockchain Toolkit. And we're going to be working with these other languages as well in order to bring debugger support to all languages that are targeting the NEO platform. So a couple of prerequisites if you want to try and do this work at home. In order to run these tools, even if you're not a C# developer, you do need to install the .NET Core 3.1 SDK. Microsoft literally released a new version of it yesterday, so I had to reinstall the old version of it to make sure that it was all working. But whatever the latest version of the 3.1 SDK, you should be fine. I'm running on this machine Python 3.8, but the Python tools work with Python 3.6 and later. We're using Visual Studio Code. That's Microsoft's developer tool that's written in TypeScript that runs across platform and in the browser with their new code spaces effort. If you're running on Linux or Mac, there's a couple of additional things you need to install. With Linux, you use apt. With Mac, you use brew to install these additional packages. There's also here a URL to documented quick start. Most of what we're going to go through here today is also in the quick start. So if you want to follow along, if you're the kind of person who does better with text, feel free to go take a look at that toolkit, quick start, and you'll be able to follow along most of these same things we're going to do here today. That is written for C#. There will be a new version of that that supports Python coming out real soon now. So I mentioned earlier the NEO Blockchain Toolkit. This is the branding that we use for a series of tools that we ship out of the Seattle office of NGD that make it easier for people to build decentralized applications that target the NEO platform. There are 5 different things that we're going to be talking about today. The first is the debugger. We want to be able to step through our contracts in a debugger to be able to inspect them, understand how they're actually operating. We have the visual dev tracker. If you're familiar at all with blockchain, you're probably familiar with explorers and trackers. There's in the NEO space, there's NEO Scan and NEO Tracker. The visual dev tracker is a similar type of tracker specifically tuned for developer scenarios and integrated directly into Visual Studio Code, excuse me, not Core. These web-based trackers like NeoScan, they're primarily focused on scanning mainnet or testnet. We want to be able to scan locally running NEO blockchain instances as well, which is why we have this tool integrated into Visual Studio Code. NEO Express is a developer-focused blockchain instance. So NEO ships a GUI and a command line tool for, in fact, the consensus nodes I mentioned earlier run on the console tool. NEO Express is a sibling to those tools that's designed for developer scenarios. So it makes it very, very simple to set up a new blockchain instance, to run it locally, to deploy contracts, invoke contracts, transfer and claim tokens, all of these types of things that you need to do in these developer scenarios, but running locally on your machine rather than needing to deploy any kind of cloud-based infrastructure. They're also primarily focused around a variety of developer scenarios like password management, accounts on your, real accounts on your real NEO mainnet, or you need to keep very good control over the security of those accounts. But in a developer scenario, that extra security, or not extra security, that valid security is like extra sets of steps that you have to go through. So NEO Express does away with that. Accounts in the NEO Express world don't have passwords. You can also checkpoint and roll back the blockchain. Obviously, the blockchain, a mainnet deployed blockchain, is ever growing. It just continues every 15 seconds to deploy a new block. But in a test environment or a developer environment, you oftentimes want to make sure you're running from an exact, the right known location, or you want to be able to go back and forth in time. And so having tools that allow you to control that blockchain, you would never use them in a production scenario, but they're critically important in a developer scenario. We also are going to be seeing 2 different compilers today. Neon is the NEO compiler for .NET. This is how you compile C# or Visual Basic written contracts to run on the blockchain. And NEO BOA is the Python compiler. As I mentioned, a new version is being released this week. I think it released today. This new version includes support for the contract debugger. So we're going to see this here live and in person. So if you want to install these tools, there's the Visual Studio Code extensions. You can go to this website and it will redirect you to our marketplace page. You can also search directly inside of the Visual Studio Code for the NEO Blockchain Toolkit and hit that green install button. It will automatically install the Blockchain Explorer, the Visual Dev Tracker, and the debugger. There's also these command line tools. So for installing the NEO Express and the Neon compiler, you use the .NET tool install operation. We also have a set of C# based templates so that you can get up and running. We'll see this in practice here in a few minutes. And then you can also install the NEO BOA via the PyPy package management using pip. So let's write our first smart contract. For this, it's going to be very simple. I'll do this live here in a minute, but I do have a couple of slides. So we're just going to, move to our home directory. We're going to call .NET new NEO contract hello world and build it. And then we're going to take a look at it in code. Very simple. It's going to look basically like this. This is the simplest type of contract we have. This is, as you can see, just normal C# code. You write a main function. And in this example, we are actually going to insert hello world into storage. Every contract in Neo has its own dedicated storage space. It's a key value store, and as you can see here, we're using hello as the key and world as the value. This information is stored as byte streams, like just byte arrays, but for the convenience of the developer, since strings are so often used, we have APIs that if you provide a string, we will automatically UTF-8 encode it and store it as a byte array. A similar implementation here in Python. Again, the whole point of this is it just feels like normal Python. We write a main function. We're going to call the get context function that we imported from the BOA interop Neo storage package. We're going to call the put function. And then here we're actually doing a separate operation. We're using the print function. In Neo, we have an operation called notify, which allows you to, and log. We have log and notify, which allow you to write information so that you can see it after the fact. Log information, this is very common in programming. We've automatically wired up the print function so that it's wired to the Neo log. So what we'll do here is we'll actually see this stuff live. So I'm going to switch over here to my my Visual Studio Code window. I've automatically created, this is just a completely empty directory. I don't actually have anything in here. I've already created the directory. So I'm going to say .NET new Neo contract. And it's now created these files. So here's that file we just saw a second ago. There's some extra stuff here for assigning metadata. You can ignore that for now. So this is automatically created contract. It's got all these red squigglies because I haven't restored or compiled it. So I'm now going to compile. And because this is Visual Studio Code, I have to configure a build task. And this is very simple. I can just say, I'm going to create a .NET Core build task. And so now when I hit Shift Control B here, you know what, I'll do most of these, instead of doing these from the command line, I'll do these from the menu, so that way you can see what I'm doing. So I'm going to run the build task. And then we bring down here, we'll notice that it's actually running build. So this first step here, this is just the Microsoft build engine, nothing out of the ordinary. But as part of this build process, not only are we producing this DLL, we're also running the Neo compiler MSIL, Microsoft Intermediate Language. That's part of .NET. This is the output of the Neon tool. So if we come here and we look in the bin directory, we'll see there's the Hello World DLL, but then there's also Hello World AVM. This AVM file, this is a binary file. This is the format that the Neo virtual machine uses. And the AVM DBG info, this is the debug information that the compiler uses to be able to drive with the compiler. So now we can actually come over here. Actually, you know what? I'm going to do one other thing before we do that. I'm also going to bring in there's no template engine for the Python stuff yet. So I've pre-written the Python one. So I'm going to copy this hello world, so you don't have to watch me actually write it. So again, this is that same exact code that we saw on the slide. Now, if I wanted to, I could set up a task so that way I could automatically build this, but I'm just going to run this directly from the console because you only have to do it this one time. And I'll just pass in neoboa pi hello, and it will automatically generate, again, the AVM file, the AVM DBG info file, and this other ABI. This is all stuff that's generated by the compiler. So you see it up here for the C# one, and you see it here for the Python one. So now let's see the debugger in action. So I'm going to come over here, and this is the debug tab, and I'm going to create a launch.json file. And you'll notice here that I have, let's do this real quick. Let's close this down. So it was automatic, since I had a Python window open, it was assuming I wanted to debug the code using the Python debugger, which I did not. So here you'll notice that I have a couple of standard environments. This is stuff that I've installed into Visual Studio Code, PowerShell, Python, but you'll notice one of them is Neo contract. So I'm going to select that, and it's going to generate this file called launch.json. This is the tool, that the file that Visual Studio Code uses to drive the launch experience of the debugger. And you'll notice that we actually have two configurations. What the debugger has automatically done is it's gone out and looked for every AVM file in the workspace and created a configuration for it. So you see there's one here for Pi Hello, and there's one here for Hello World. This is why I wanted to bring the Python file in ahead of time. That way I didn't have to type all this stuff out. I could just automatically bring it into space. So I'm going to select the Hello World AVM, and I'm going to start debugging. And so here we are in the debugger. So there's a couple of things to note. This is a very simple contract. We'll look at a more complicated contract later, but you'll notice we have two sections of storage of variables here, locals, and we have storage. We have a call stack. We can set breakpoints. We'll look at breakpoints later. This code isn't long enough to be able to really have interesting breakpoints. But I'm going to step into code, and I'm about to call this function that's going to put something into storage. This doesn't have any local variables, so we don't have any locals set. But if I do the next operation, we'll notice that something showed up here in storage. So this is a unique key, and it's generated so that way it's contract information specific. But I have this information here, so I can now see what this contract is inserted into storage. Now, because this is a virtual machine running in the debugger, there's no actual, this information isn't really stored. I mean, it's stored in memory, it's not stored persistently. We're running the virtual machine in an isolated environment that simulates the blockchain storage. But it isn't actually, storing this in the blockchain. We can control this. We can put emulated information into the emulated storage. We can even read a blockchain checkpoint so that we can have real blockchain data while we're debugging a contract, but we're not seeing that here today. Now, this is this byte stream. I mentioned here that we automatically convert strings into byte arrays. It's a lot harder as a developer to read that byte array. So what I'm going to do is I'm going to add that to the watch window. And I can actually then do a cast operation to say, hey, I'd like you to treat that as a string. And we can see here that it's now created the word hello. And I can do the same thing with value. There's a variety of different types that the compiler can understand. I can say, hey, I want you to treat this as a byte array. You have to spell it correctly, as it turns out. So now I can actually inspect that on a byte by byte basis. Or I can say, hey, I want you to treat this as an integer. And so this is the integer version of that. I can even say, hey, I want you to treat it as a Boolean, which is very simple since it's basically any value that's more than 0 will default to true. Of course, this isn't really a Boolean or any of those. This is a string. So that way I can say, the emulated storage doesn't know what this value, where this value came from. It doesn't know that it was originally a string. So this gives the developer more power to be able to understand what's actually happening inside of their tool. Now we can also come over here and we can look at the Python one. You'll notice we have an identical experience. Everything in the NEO Blockchain Toolkit has been designed to be language neutral, the same way that NEO supports multiple languages, the NEO Blockchain Toolkit supports multiple languages. And that includes the debugger. So here we go, and we are going to step. Now you can see here that there's much more information in local variables here. There's a variety of unnamed variables. So this is information that the Python compiler, NeoBOA, generates. It has some information that it needs to do in order to store running state. And so as we step through, we'll see that the very first thing it's going to do is it's going to create this context, which is this big byte array. Then it's going to call put. You can see here storage is empty. And you can see here that because the key here value is the same, we actually get our watch window automatically pre-populated. And then finally, we're going to run this print operation, and we'll see here that it shows up here in the debug console. So this, we see hello world, and we see the return. So this Python print function gets mapped to the runtime log function. And in this case, we're returning a value, which is just 0. That's it. So it took us less than 5 minutes, and we already have got a simple, very simple, obviously, smart contract up and running in the NEO smart contract debugger. But as I said earlier, this is running in the debugger. It's an isolated environment. It's not really running in a real blockchain. For real blockchain development, you can't just use the local VM like this. You oftentimes need to actually have an actual real running blockchain. And that's where NEO Express comes in. So we're now going to talk a little bit about local blockchain development using NEO Express and the Visual Dev Tracker. Now I had like 12 slides of like screenshots, And what I decided is that you guys would probably rather just see me do all that stuff live. So I'm going to work a little bit without a net here, but let's actually get this stuff up and running. So I'm going to close this down here. We don't need any of these windows open. And I'm going to bring back the terminal windows because I'm going to probably need that at some point. And you'll notice here that on the this icon bar here on the left-hand side of Visual Studio Code is the Neo logo. So this is the Visual Dev Tracker. So I mentioned earlier that the two big pieces of the Blockchain Toolkit, the two extensions to Visual Studio Code, one is the debugger that we just saw, and one is the Visual Dev Tracker. So Visual Dev Tracker allows me to inspect different blockchains. So you can see here that these are all the nodes that it knows about for talking to the blockchain, to the main blockchain. This is talking to mainnet. So this is live data running on mainnet. So you can see here, I can click, this is the list of the most recent blocks, and I can say, hey, I want to look at this specific block, and I can see that in this block, there's a bunch of transactions, and in each of these individual transactions, okay, that's taking a little longer than expected. Oh, there we go. Here's the information about that transaction. I can see that this was a claim transaction for this account, claimed this much gas for this much NEO. I can look at this individual address. Now, this address does not have RPC support for several operations that we need in order to get information about accounts. So we'll look at this again here shortly. So this is great. This is you know, again, the kind of tracker explorer experience that you would expect to have for any blockchain running on mainnet. But what we really want is to create a new instance of NEO that we're going to run locally. So what I'm going to do here is I'm going to create a new, I'm going to just go to this menu here and click create new NEO Express instance. I'm just going to bring up this little dialog. It tells me where do I want to put it, what do I want to call the file, and how many nodes do I want to run. So normally on a production blockchain, you're going to have you're certainly going to have more than one. You'll have either 4 or 7 nodes. But because this is a developer blockchain, it is oftentimes more convenient to run one. There are several functions that Neo Express supports, like that blockchain checkpoint and rollback, that only work with a single node blockchain. So that's what we're going to do here. We're not going to create a 4 or 7 node one. We're just going to create one, and we're done. Now, you'll notice here that there's a little bit of a warning here. I mentioned this earlier. The private keys for the accounts in this file are not encrypted. Do not use these accounts on mainnet or any other system where security is a concern. I mentioned this earlier. Neo Express does not encrypt any of its private keys. That makes it really, really convenient as a developer to write code. It also makes it really, really easy to lose your assets if you decide to use these private nets, these accounts on a public blockchain. We come back over here, close these folders down. You'll see there's this new file called default.neoexpress.json. And this is just a JSON file, and it has the information that all the information about this blockchain. So this is a single node instance. So there's only one instance in this consensus node, and there's information about how to connect to it over the network. And here's the information I mentioned. The private key is completely public. So I wanted to point that out. I'm not kidding about this. These are completely and utterly insecure. In Neo, each individual node has its own address, and then it shares one address. Of course, here there's only one node, so it's not really shared with anything. But there's this address, this multi-sig contract, which is where all of the assets are given. You know what? Let me bring up one other slide here that I was not originally going to talk about, but I'm going to anyway. One second here. One thing to understand about Neo is that it is a dual token blockchain. So most blockchains are only single node or single token, not all of them obviously, but a lot of them. So in Neo, you have both Neo and gas. So when you create a Neo blockchain, it has 100 million Neo and 100 million gas. However, the way that those Neo and gas are doled out is very different. 100 million Neo are minted automatically in the Genesis block and given to that multi-sig account that I was just showing you. The gas is distributed to Neo holders over time. So every block that gets created, I believe it varies with time because it decreases over time, I believe. But at the beginning, there's like 16 gas that are given for across all 100 million Neo. every single block. And the NEO is the governing token, and gas is the utility token. And in particular for developer scenarios, gas is used to pay for things like deploying and invoking contracts. So in order to be able to do anything of interest, you actually have to have gas. So let's come back to our demo without an app. So I've now created this blockchain, and you'll notice that if we come back over here to our Visual Dev Tracker, we now have a separate instance here. Now, I'm going to run this, and it's going to start an instance of the blockchain right here inside of Visual Studio Code. And if I now click on this, I get that same exact experience. I'm going to close this window now. I get that same exact experience that I had before. I can click on a block. Now, this is just started, so there's only 2 blocks so far. But I can click, well, there's 3 blocks now. I can click on a block. I can see the information about the transactions. I can click on there's information about the transaction. I can click on a specific account, and I get information about accounts. Now, earlier we saw this. We couldn't get the information about the tokens that were owned by an account because the RPC server that I was connected to on mainnet didn't provide that functionality. But of course, NEO Express does. So I can see here that this account has 100 million NEO, as I was just mentioning, and it's got 24 gas so far. I guess it's 8 per block, not 16, my bad. Anyway, so now this is great, but we want to actually use this. We actually want to use this. Now I'm going to do something that a little bit different here. I'm going to stop that instance of blockchain, and I'm going to run over to my console here, and I'm going to start it. I'm going to use NEO Express on the command line. Now, the reason I'm doing this is that in this current version of Visual Dev Tracker, there's a feature, and this is a feature that's been added in a later version, but that hasn't shipped yet. We want to be able to, there's a couple of things you can control when you go to run the blockchain. So if I hit like the question mark, you can see here that there are a couple of specific operations. In particular is this seconds per block. In production on mainnet, NEO creates a new block every 15 seconds. For a developer, that means that if you go to do an operation, you have to wait 15 seconds to see whether it worked or not. That gets very old very quick as a developer. Also, as we were just talking about, you want to have a lot of gas in order to be able to do operations like deploy and invoke contracts. So instead of running it at the default 15 seconds per block, we can actually run it faster than that. So that's what I'm going to do here. Is I'm going to run this blockchain, and it takes the first block as it's getting set up takes a little longer, but as you see here, it's creating 1 block every second. And we're going to let that run in the background, and we can still now connect to it. If we come back here, we'll see that these are popping up very fast. Now you'll notice here that the vast majority of these only have 1 transaction in them. If we click on any one of these sort of at random, you'll see that there's what's called a minor transaction. In NEO 2, which is all of this stuff, by the way, is NEO 2. We will be supporting NEO 3. We're working on the NEO 3 implementation of all this stuff now. This is basically an empty block. This minor transaction is really just a bookkeeping thing. So it gets like there's a lot of noise here. So for NEO Express, Visual Dev Tracker knows that it can hide empty blocks. So by clicking on this, now we're only going to be looking at blocks that have more than just the minor one. And so far, we only have the Genesis block here. So let's change that. So I'm going to start by creating a new wallet for us to use. And I'm just going to use my name, DevHawk, for this new wallet. And it's going to pop up, create the wallet, and it's going to remind us again, not encrypted, do not use these accounts on mainnet. I'm going to keep stressing that because it's important. And so now I'm going to transfer all of those assets from the Genesis account. You can see here, I clicked that. This is the transfer asset. I went a little fast there. I'm sorry about that. I just right-clicked here, and I have this list of things that I can do, and I'm going to transfer assets. So I just click this menu item. So I'm going to pick the source. I'm transferring from Genesis. I can click the target. I'm transferring to DevHawk, and I'm going to transfer all 100 million NEO to that account. And now, again, because we're creating a block every 15 seconds, every second, this information is immediately available. I don't have to wait for it. I can see, here's the information about the transaction. This was a contract transaction, which in NEO terms means it was a transfer. I can see the output. So I can now see that this account, which is the DevHawk account, has 100 million NEO in it. And if I go back and I look at the Genesis account, we can see that it has no NEO in it. It also has gas. So gas, as I mentioned, is the token that's used for paying for things. And you'll notice here that the Genesis account has 872 available gas. And if we go over to the other account, it has 0 available gas, but it has 344 unavailable gas. So you get gas for every block. However, that gas is unavailable until you actually spend at least some of your NEO. Now, it turns out you can just send NEO to yourself in order to spend it. But since we already have gas that's available in the Genesis account, we can also just say, hey, let's claim that gas. So I'm going to claim that gas and go to the Genesis account. And it'll say, hey, you've got 872 gas that you can claim. So I'm going to do that. And again, it goes very fast because it's all running locally. And I can see now that I've acquired this 872 gas. So this is still that Genesis account. And now I'm going to send this over to I'm going to send that to the DevHawk account too. And so now we can see here that the DevHawk account has 100 million NEO, 872 gas, and we have more gas if we need it, but we don't really need more than that. It takes 500 gas to deploy a contract, and then invoking a contract depends on the size of the contract. For the Hello World contract that we're going to deploy, it doesn't require anything more than that. So now I'm going to deploy the contract. So I'm going to click the deploy contract button here, and I'm going to pick the Hello World contract, and so it'll show me some information about the Hello contract. And I'm going to say I want to use the DevHawk contract to do this, the DevHawk account. That's what's going to pay for this transaction. And I'm going to click deploy. So now again, I can click here and I can see information about the transaction. This is an invocation transaction because we're invoking there's a smart contract native to NEO called deploy. And so we've invoked the deploy contract. And there's information here about that contract. And we can look here at the application log and we can see that the state at the end of the contract was halt. Halt, it means that it's successfully completed. If it had unsuccessfully completed, it would have faulted. So now that we've actually got that contract here, and I'm gonna, just to show you one quick thing, we're gonna be adding these features. Again, there's a couple of features that are in the command line that are not yet in the dev tracker, but we will be adding those over time. NEO Express contract list. We can see here, oh, okay, that looks like a bug. Well, let's see if we can actually invoke the contract. So let's close that down. We can see here that it's reading information about the Hello World contract, and it can see that there's a single method called main, and I'm going to broadcast this. It turns out that there's a variety of ways that you can invoke this. You can launch it in the debugger, which we talked about, but we saw before. And then when you're actually invoking a contract on NEO, you can either call it or you can broadcast it. And the difference is that if you do a call method, you can get data out of the blockchain, but you can't change any data in the blockchain. So if you have a read operation like, who's the current owner of this account, you can do that with a call. If you want to add and change things in the contract, in the blockchain, like I want to register a new asset, you have to do that with broadcast, and broadcast costs. So I'm going to pay for this out of the DevHawk account, and I'm going to broadcast this transaction. And we can see here that it's created this contract. So even though my list function has a bug in it, you can see that we did actually successfully invoke the contract and it did halt. Now, the thing here is, how do we actually know that it worked? How can we see that? Well, as you can recall, this contract is writing information to contract storage. So what we can do is we can actually look at the contract storage from the blockchain that's running in the background. This is a feature that's going to be coming in the next version of Visual Dev Tracker, but we can also do it on the command line. So if I say NEO Express contract storage, you actually have to spell it correctly. And then I pass in a path to the AVM file. It's invoking a special RPC endpoint to pull the information about all of the contracts. So we can see here that this contract has these values. The key is hello, the world is the value is world, and it's not constant, which means that it can be updated and modified. So this information is there in the blockchain, and we can actually see it We just can't see it yet in the Visual Dev Tracker. As I said, we are adding a storage explorer in the next version of Dev Tracker, which should be released here in the next month or so. So we've now seen building out a very simple contract. We've seen how to create a local instance of the blockchain and how to deploy that contract, transfer assets, and those types of things. As I mentioned, there's a couple of other interesting features about the Neo Express. I want to show you one other one before we move on to a slightly more complicated contract. So I'm going to shut down the blockchain that's running, and I'm going to do something called create a checkpoint. So I'm going to say check, again, I have to still spell it correctly, checkpoint, create, and I'm just going to call it CP1. So what this has now done is it's actually created a checkpoint. If I do a directory, you can see here that we've created a file called cp1.neoexpress checkpoint. All we've done is we've zipped up the contents of the blockchain and stored it in a file. Now, the reason that that's interesting is that if I now run the blockchain, we'll see here that we're currently at height 464. And we'll let this run here for a few seconds, 464, 465, blah, blah, blah. And I'm going to shut it down. Now, if I start it again, we can see here that we ended at 470. It didn't actually finish the 470 block, so it starts again at 470. So you can see every time I run the blockchain, it just picks up where it left off the last time. So now what I can do is I can say I want to checkpoint restore. And I'm going to give it the path to the directory, and I have to tell it force. That's just a safety precaution, so you don't accidentally overwrite stuff that you didn't mean to. So now what it's done is it's now rolled back my blockchain so that I can actually, if I run it now, we can see we left off at 476. If I run it now, we're back to 464. So all of that stuff that we ran, it's all been thrown away and we rolled back to 474. You can have as many different checkpoints as you want. They're just individual files, and you can restore them however you need. It makes it really convenient for managing a development project. You can take a snapshot at the beginning, you can deploy your contract, you can take a snapshot after, you can invoke the contract, you can take another snapshot. So that way, as you're debugging and trying to work through things, you can try and figure these types of things out. Also, it's just a file, so you can share it with your teammates. You can check it into source control. It is it can get to be a large binary, so the normal constraints on large binaries in Git repos still apply, but you can, in fact, they're just normal files. There's also a really cool feature we have where we can actually run a checkpoint. So you can see here that we ended off here at 511. If I say neo checkpoint run and pass it CP1, what this is now going to do is it's going to use the information that was in the checkpoint on disk, but then any changes to it are going to be stored only in memory. So you can see here we've gone back to 464. We didn't actually have to restore it, but each of these new blocks that come out are only being stored in memory. So when I shut this process down, it'll automatically throw that information away. I didn't pass the seconds per block to be 1. Checkpoint run supports that as well. So this is creating a block every 15 seconds. So even though this is storing information in memory, if I come back over here to my Neo Express, and it's going to take a few seconds because it's running at 15 seconds here. Let's run this at 1 second. That's faster. You can see here, even though I stopped and started it again, it rolled back to 464. And I'm going to close these windows down. And you can see here that these blocks are just getting created. So the experience of working with this, whether you're working with a checkpoint or you're running the blockchain for real, is exactly the same inside of Visual Studio Code. And again, I can hide these empty blocks. And so I can just see the blocks that were interesting. So these were the various transfer, blockchain deploy, contract deploy, and contract invoke operations. So back to slides. So I want to now look at a more complicated contract. We have about 15 minutes left. I don't know how we're doing questions for this. So if somebody can let me know how questions work. I would really appreciate that if there are any questions here. But I'll try and leave another like 5 or 10 minutes at the end for questions as well. So this is a contract example. We have versions in both C# and Python. The URLs are here. And this is demonstrating a much more complicated scenario. Contract parameters, return values, support for multiple operations, reading and writing storage, witness validation, and configuring the storage in an emulated debugger. So let's come back over here. I'm going to shut down this instance of Visual Studio Code, and I'm going to change directories to the domain folder. Because I'm personally more comfortable with C#, we're going to be doing this with C#, not the Python one, but everything I'm about to show you works just fine with Python as well. So here's the contract for the domain. This is a simple like DNS type of scenario. So I'm going to be able to, there's 4 basic operations I can do. I can query the status, who owns a given domain. I can register it, I can transfer it, and I can delete it. This is a very common pattern in Neo, where you have the main function has a string that takes in the name of the operation, and you have a case statement that dispatches it to the right function, and then you pass in the arguments as an array, and then you, as part of that dispatch, you break the arguments out and by their types. And you can see here in query, this get function is essentially the opposite of the put. So we're just going to say, hey, I want to get some information from the current context about the domain. Register is going to, first thing it's going to do is it's going to check the owner. So check witness is a way of being able to make sure that the person that's being passed in as a parameter is also the person invoking the contract. And by default, and we'll see this when we look at the launch configuration file, this is hardwired in the debugger to just return true. But you can control this, you can tell it what you want your witnesses to be, and there's all kinds of things you can do to control this. But for debugging purposes, normally what you want is just to return true. You just want to bypass that check. So here we're going to get a data out of the contract, we're going to get data out of storage, we're going to check to make sure it's null, and we're going to return true or false based on that information. And then assuming that we don't return, assuming that it's not null, then we will actually register this domain. So we're now going to take a quick glance at, I've already compiled this, so we don't need to go through that step, but I'm going to look here at the launch configuration function, or launch configuration file, and we can see that we have a variety of different configurations here. I haven't wired up every one of the operations, but I've done for both query and register, I want to query when there's already a registered, when that account is registered, and I want to query when it isn't. So query empty means I want to do the query when there isn't any data stored for that account, and query full means that it is. So you can see here, first off, we have the path to the domain, to the script, the AVM file, and we have arguments. So if you've ever worked with Visual Studio Code, like the C# debugger or anything like that, this is just a JSON array. And in this case, we're giving it, as I said, the first value is query, that's the name of the operation, and then you have a collection of arguments. In the case of the query operation, there's only a single parameter, it's the domain, and it's a string. So here we're passing in the domain, and we're going to use neo.org as an example. I mentioned earlier about the check result. Here you can see that you can control that here in the configuration. I can make this true, I can make this false. I can also pass this a list of addresses that it validates against. You can also see here that I have this value called storage, and storage is empty. But if I scroll down here, you can see here for query full, I'm actually going to assign storage. So we can actually pre-populate the storage, the emulated storage for whatever scenario we want. And again, the same way that we do in code, we automatically will take strings like neo.org and UTF-8 encode them. So now I'm going to come over here and we're going to see this run in the debugger. So I'm going to call the query empty, and you can see here that I can step through. Now, one thing I want to show real quick is a brand new feature that's going to be shipping very soon, like within the next week or two. I'm actually running a preview of the 1.1 release of the debugger, and we've added support for disassembly. So this is source level debugging. So this is seeing what it looks like from C#. But under the hood, NeoVM is executing a series of bytecodes. And so this allows me to switch back and forth from those bytecodes. Especially for language developers like the folks who build the NeoBOA compiler, this experience is very, very useful. And you'll notice here that we have the, this is the instruction address, and then in blue is the actual instruction name. And unless you're an expert with Neo as a VM, this is going to look like gobbledygook, so we're not going to spend too much time on it. But then it also does automatic decoding. Like, for example, this function here right before where we're stopped is a jump to position 190. So this 5B00 is a jump, but we automatically decode that. So as a human being, you can automatically tell. You can see here, for example, this push bytes is a bunch of bytes, and that's the string transfer. If I scroll down a little bit here, you can see that we have a syscall, and the syscall is this this byte or this UTF it's just a 32-bit number, but that's Neo stored get context. So we automatically will decode all of this information to make it easier for the language developer to be able to understand it. But since we're not doing a language scenario, we're going to switch back to source. I just wanted to show that off because it's coming real soon and I'm pretty excited about it. So as I mentioned, since we know we passed in query, you can see here that if I hover over the word operation, I see the word query. I can see the word query here in my local variables. I can also see args, and you can see here that my args array is a single byte array. Now we happen to know that this is an array. Sorry, of course it's an array. We happen to know that this byte array is really a string, and I can, as we did before, I can add this to the watch window. I'm going to remove this one, and I can put string in front of it, and we can see here that it is in fact the string we were expecting. However, when we do this cast, you'll notice that in the string function, it automatically knows that it's a string. Since C# is a statically typed language, you wouldn't get this experience in Python, what I'm about to show. As I step into the query function, we'll now see that the domain variable is in fact a string. So it's able to use this type information in order to provide the best possible experience here in the debugger. And I'm going to step again, and it's going to return a get, and we're done. But I've shut down the debug window, so let me open that back up. We can see here that it returned 0 because there was no value. So now let's switch over to query full, and we'll walk through the code again. Actually, you know what? Let's do this. I wanted to show this. I'm going to set a breakpoint. So just by hovering over here, I can create a breakpoint. So you can see here I've created a breakpoint. If I hit run, it'll automatically stop at that point. By the way, I can set breakpoints both in the source and in the disassembly, and they'll stop, and that view will just automatically, whichever view you're currently in, it'll just stay in that view. But you can switch back and forth. You can set breakpoints either way, what have you. So now we're going to call this get function, and it's going to return a value. And when we come out, we'll see, oh, okay, well, this is neo.org in hex. That's great, but that's not very useful. So unfortunately, we can't use any, we don't know what its type is because it's getting cast back to an object. So, and again, as I mentioned earlier, in Python, you don't have this kind of type information. So what we're going to do is we're going to add some more information to the launch configuration. We're going to add, you can notice here that there's a variety of different types here, things you can set. We're going to set return types. And so return types is just a JSON array, and you can tell it, I want you to treat this similar to what we were seeing in the watch window. I want you to do the same thing for return types. And we're going to pick string. So we want you to return that value as a string. So now when I do the query, I'm just going to run this and run it again. You can see here that it returns Neo Foundation. So it actually does that conversion back to a string automatically for you. So now we can see register succeed. Oh, one other thing to show about full. I almost forgot. So as I mentioned earlier, we have storage. So you can see here that the storage information, this is storage that was pre-populated by that launch configuration, right? So we automatically pulled that information to say, yeah, I want you to have, that's where that Neo Foundation word came from. So now let's run register succeed. So here we're going to attempt to register a new domain when it hasn't already been registered. So we're going to start debug. And again, we're going to step in. This time we're going to the register function. Now again, here we're going to see check witness. Now check witness will automatically return true because it's hardwired because it's running in the debugger. And then we're going to attempt to get the current value. and we can see here in value that it's 0. So this is an empty array, basically, which is the null value. So we're going to check that against null, and that'll succeed. So then we're going to put a new value in. You can see that new storage showed up. So this is domain is neo.org, and the owner is, again, here we don't really know what the name of the owner is, but if we wanted to add it to the watch window, we can automatically get it as a string so we can actually understand what we're looking at. So we've now put that value into storage, and we can see it right here, and we're returning true. And I've already configured in the register succeed, you can see I've already configured the return type. So we get that value as a Boolean. So we see it's actually true. So then for the last one, before we do questions, we're going to do register fail. In register fail, I'm going to try and register neo.org myself, but it's already registered to the Neo Foundation. So now when I run this code, we do the check witness, we do a get, and we can see here that there is actually a value. If I did that watch window, it would be Neo, it would be Neo Foundation. We already seen that like 4 times. We don't need to do it again. That value will not be null, so we will then return false. You'll notice here, by the way, that some languages like Python are line-oriented. In C#, it is still possible to have expressions, multiple breakpoints or multiple sequence points on a single line. So that's what's happening here. So we saw the first step or part of this line, and now the second step, we're going to return false, and we're going to return out, and it's going to cast out false in the debug window. So we've seen now, let's go back to the actual slides. So we saw today, I guess I didn't have a summary slide, that was a mistake. We saw building a very simple contract, hello world. We saw building it in both C# and in Python. We saw how to create a Neo Express instance that's running locally, and your own instance of the Neo blockchain running in a developer tool. We saw how to communicate with that via Visual Studio Code in the Visual Dev Tracker. And we looked through how to do more complicated debug scenarios with things like managing storage, managing return types, casting data types and watch windows and stuff like that. Again, here's more of my contact information: email, LinkedIn, Twitter, GitHub, and my blog. Thank you so much for coming. I really appreciate the opportunity to talk to you all about this. And if there are any questions, please feel free to answer, open them now, or if you want to contact me later via one of these mechanisms, that would also be great.
All right, awesome. Thank you, Harry, for joining us today. We do have a few minutes here. I know we have a couple attendees in the room. I just want to make sure I give them time. Feel free to post in the Q&A, or if you want to ask a question, you're allowed to. So I'll give you guys a few minutes there. Great presentation, Harry. Thank you for breaking it down.
No problem. Happy to be here.
Again, this is recording, so this will be posted under the workshop tab in the Reimagine 2020 website. So feel free to access this at any point. This should probably be uploaded with a little editing, and probably towards the end of the week as this conference settles down. So that should be posted in the next 72 hours, if not sooner. And that's pretty much it. So I don't think we have any questions at the moment. As you can see on the screen, that's how you can get a hold of Harry here. Email, LinkedIn, Twitter, GitHub, all the above. So, all right. Well, I think that concludes for today. Again, Harry, thank you for joining us and presenting this.
No problem.
All right, guys. Thank you all. Have a good one.